as we've been reporting, lots of people in Russia had a huge shock today when a 9-ton meteor fell through the sky. It sparked explosions and panic in the central part of the country. And it happened just as a big asteroid is expected to whiz past Earth later today. Rest assured, though, scientists say this one will not hit the planet. Ivan Semeniuk is a science journalist who's following both stories. He joins us now by Skype from Boston. So, Ivan, first of all, how surprised were you that the meteor struck central Russia?
Well, of course, these kinds of events could happen anywhere in the world. There is an interesting coincidence, though. This is, if the numbers that we're seeing so far hold up, this will be the largest object to enter Earth's atmosphere since the Tunguska event of 1908. That was also over Siberia, sort of a little bit further out, but still basically over Russia. So it's interesting. It seems like Russia, seems to be the recipient of these events, but in fact, they could happen anywhere on Earth.
So it's a relatively rare but not unheard of event. I tend to assume, I mean, we hear so much about meteor showers, so why is it so rare, Ivan?
Well, of course, these impact events get more rare the larger the impactor. There are just more smaller pieces flying around out there than there are larger pieces. So when you talk about a meteor shower, you're talking about objects that might be the size of grains of sand, or maybe up to the size of a grain of rice or a pea, entering the atmosphere, going out in a big blaze, but not a very large object. In this case, the sound waves that this object created as it entered the atmosphere, not the sounds that we can hear, but infrasound, longer wavelengths than the human ear can hear, sent energy out in all directions. And already from just those waves that were picked up by detectors around the world, we know that we're looking at something that might have been 15 meters across. So something the size of a very large room, or actually larger than a bus, basically coming in and delivering a huge amount of energy as it broke up in the atmosphere. The estimate now is something like hundreds of kilotons worth of TNT. That equivalent energy was deposited in the atmosphere.
So that really gives us an appreciation of the destructive power of this and the sonic boom. I mean, what makes this so extraordinary is we see it flash across the sky and we can hear it. You can appreciate why people were terrified.
Oh, absolutely. And again, the larger the object, the more energy it's going to deliver in this way. And people have not seen something like this for generations. So, and without warning, it would just literally come out of the blue. So I think it's incredible that we have so much video of it. It's incredible that there's so much documentation. I think this object is now going to be one for the history books and for scientists to study, to learn more about the nature of what's out there, this shooting gallery that surrounds us, and these bullets that are flying all around.
You know, it's interesting you say the shooting gallery, because Chris Hadfield, the commander of the International Space Station, was saying just that. It is like a shooting gallery. That's not a very confidence-building observation for most of us on Earth. How are we doing in accurately tracking all the stuff that's out there that might be headed in Earth's direction, and how good are we at anticipating what might strike Earth?
Well, NASA and, in fact, astronomers around the world have made huge strides, I would say, in the last 15 years or so. There's been this concerted effort to try to map out objects and track objects that are somewhat larger than this, perhaps objects a kilometer in size or larger. So, an object like that hitting Earth would not just turn heads, but, if it landed in the wrong place, would be just an incredible catastrophe. So the effort is to try to get at least 90% of the objects that are out there that could be a threat to us, understand where they are, and to be able to track them very closely. So great progress has been made in this area, mainly because of these automated sky surveys, where you have a computer, a camera, a telescope, scanning the sky every night, and the computers can see more than a human astronomer could see. So gradually, we're picking it up. But for objects that are somewhat smaller, like this, under 100 meters in size, there's so many of them, and we still are far from knowing where they all are.